Welcome back, my dear students. We will start with some problems. We'll continue. We have already started to and solved 2 problems in this chapter. Now we'll continue with the problems. The next problem is charges 20 microcoulomb minus 30 microcoulomb and minus 40 microcoulomb are placed at the corners A, B and C of a square ABCD of side 2 meter. Calculate the work done to move an electron from center of the square to the corner D. This problem is just like the problem which you have solved in the first chapter. But in that chapter you had to find out which one? You had to find out the force, correct? You have to calculate the force, and you had also some problems related to electric intensity or electric field. In this chapter you are going to find out you are going to calculate the work done by using the potential, expression of potential, correct? That is a small changes. You have to see properly. If they ask work done, that is related to this chapter. If they ask about the force or due to the electric intensity, it is related to the previous chapter. Okay, so let us consider a square A, B, C and D. You have to place the 3 charges at A, B and C, that is 20 microcoulomb minus 30 microcoulomb minus 40 microcoulomb, and the sides of the square is 2 meter. Correct? The sides of the square is 2 meter. You have to calculate the work done to move the electron from the center. So I will draw a diagonal. Okay? To the corner D. From the center to the D. Let the center be O. Just like previous problem, to move it from the center to O, we should know this distance which you have to calculate initially. After that you substitute and calculate. Which formula we have to use here? After placing this charge, the potential expression for the potential is 1 by 4 pi epsilon naught Q by R. Now, potential at A, potential at B, potential at C. So, potential at A. Potential due to the charge A on O is. So, before that we should know R. That R is this one. R1, R2 and R3, or RA, RB and RC. So, therefore, how to calculate? This is a Pythagoras theorem you have to use. This is a right angle triangle, 2 meter, 2 meter, then this distance is, that is AC square is equal to AD square plus AC square, that is 2 square plus 2 square, that is AC is equal to square root of 4 plus 4 is 8, or I can write 4 into 2, that is 2 root 2 meter. AC is equal to 2 root 2 meter. But OA is equal to OB is equal to OC is equal to OD in the square, which is equal to AC by 2. That is equal to 2 root 2 by 2, that is equal to root 2 meter. Correct? By using the Pythagoras theorem we have solved it. We know this is a right angle triangle. Use this square it and take the square root. AC is equal to this one. OA is equal to OB is equal to OC equal to OD in case of a square. Therefore, that is equal to AC by 2. So, we get root 2 meter. Next, use this one and try to calculate what is the total potential at the point O due to the 3 charges A, B and C. So, what is the formula? VO is equal to VA plus VB plus VC. Total potential. VA is 1 by 4 pi epsilon naught charge at A by R A plus 1 by 4 pi epsilon naught charge at B divided by RB, RA, RB and RC. So, plus 1 by 4 pi epsilon naught QC by RC. Substitute and calculate the potential at O. VO is equal to, what do we get? 9 into 10 to the power 9. See, these three are same here. So, 9 into 10 to the power 9. QA 20 micro, 20 into 10 to the power minus 6 divided by OA is nothing but root 2 plus minus 30 micro, minus 30 into 10 to the power minus 6. Divided by root 2 plus minus 40 into 10 to the power minus 6 divided by root 2. 9 into 10 to the power 9 into 10 to the power minus 6 divided by root 2. 20 minus 30 minus 40. The answer you get, VO is equal to, we got here answer as minus 3.18 into 10 to the power 5 volt. Are you getting the same? Minus 3.18 into 10 to the power 5 volt. Are you getting the same? Yes. Next, what you have to do? You have to find out the work done in moving the charge from O to D. Correct? To move the electron from the center to the corner D. So, for that, what is the potential at D due to the all three charges? That you have to calculate. Potential at D due to these three charges is potential at D due to A, potential at D due to B plus potential at D due to the C is, I'll not write directly as VA, VB, VC and all, because if we substitute that, you will not substitute this. So, therefore, I'll write potential at D due to all three charges is VD is equal to 1 by 4 pi epsilon naught Q1 or 20 into 10 to the power minus 6 divided by distance is AD. QA divided by AD plus 1 by 4 pi epsilon naught QB divided by BD plus 1 by 4 pi epsilon naught QC divided by CD. Correct? Due to this one from here to here, from this one from here to here, due to this one from here to here. So, therefore, QA by AD, QB by BD, QC by CD. Substitute and calculate. Add. CD is equal to 9 into 10 to the power 9 is same. QA 20 into 10 to the power minus 6 divided by 2 plus QB minus 30 into 10 to the power minus 6 divided by this full 2 root 2 plus minus 40 into 10 to the power minus 6 divided by 2. Correct? So what is the answer? What is the answer you get? Solve it using the calculator. We will get it as minus 1.855 into 10 to the power, we got it as 5, I think. Minus 1.855 into 10 to the power 5 volt. So now the next question is, what is the work done? You have to calculate that itself, not the potential. You have to calculate the work done. How to calculate the work done? To calculate the work done, you should know what is the potential difference between these 2 points. That potential difference into that value if you do work charge. So, potential difference is V is equal to VO minus VD. Correct? Potential difference is or VD. Where do you have to find out potential difference between? You have to calculate from, so you have to move it from center to D. So D minus VO. Substitute and calculate D minus VO. Minus 1.855 into 10 to the power 5 minus what do you got? 3.18 into 10 to the power 5. What is the answer you get here? Minus of minus is plus. So minus 1.855 into 10 to the power 5 plus 3.18 into 10 to the power 5. Subtract subtract 1.855 from 3.18. What is the answer? 1.325. Into 10 to the power 5 volt. That is potential difference between VO and VD. Therefore, total work done in moving the charge is V into the charge. That is here to move the electron. So, therefore, 1.325 into 10 to the power 5 into 1.602 into 10 to the power minus 19. What is the answer you get here? What is the answer you get? 212.6. We got it as 212.6 into 10 to the power minus 16. Joules of work is done. 212.6 into 10 to the power minus 16 joules of work is done. Unit for work done is joules, so I can write joules. Or else you can write electron volt, because charge is Q. Electron volt, if you don't substitute, you can write it as now 212.6 into 10 to the power minus 16 joules of work is done. Simple and easy, but here the difference between the previous chapter and this chapter is, there you are substituting with the expression of electric field and force. Here you are using the expression of the potential energy, potential, electrostatic potential. The next, solve one more problem. Charges, point charges, plus 2 nanocoulomb, plus 4 nanocoulomb, plus 2 nanocoulomb, plus 4 nanocoulomb, and plus 8 nanocoulomb, are placed at the corners A, B and C of a square of side 0.2 meter. Calculate the work done to transfer the charge. Transfer or move a charge two into 10 to the power minus 9 or 2 nanocoulomb from D to the center of the square. From D to center of the square. Charges plus 2 nanocoulomb plus 4 nanocoulomb and plus 8 nanocoulomb are placed at the corners A, B and C of a square ABCD of side 0.2 meter. Calculate the work done to move a charge 2 nanocoulomb from D to the center. The earlier problem was of you have to move an electron from the center to the D. Now you have to move it from D to the center of this square. So what you have to do, just like previous problem, try to solve. Try to solve. Rough diagram of the square. Place 4 charges at A corners A, B, C and D. 2 nanocoulomb, 4 nanocoulomb and 8 nanocoulomb. Center O. But the sides 0.2 meter, 0.2 meter, 0.2 meter. So we will first find out what is the value of AO. So for that, square root of 0.8 meter. That is how much? We get it as 0.283. Are you getting the same? Square root of 0.8 is not 0.8. Sorry, 0.2 into 0.2 is 0.04. So you add it. So we'll get 0.283 meter. Take a calculator and solve. But we want OA. So OA in a square, OA is equal to OB is equal to OC equal to OD is equal to AC by 2. That is equal to 0.283 divided by 2. What is the answer we are getting? 141. I think 1415 something you get. So 0.141 meter. Next what you have to do? How can we solve it? Next step. Total potential at O due to the 3 charges. What is the total potential due to 3 charges? VA plus VB plus VC. 1 by 4 pi epsilon naught 2 into 10 to the power minus 9 divided by which value? OA plus 1 by 4 pi epsilon naught 4 into 10 to the power minus 9 divided by OB plus 1 by 4 pi epsilon naught 8 into 10 to the power minus 9 divided by OC. Calculate. What is the answer you are getting? VO is equal to 9 into 10 to the power 9 into 10 to the power minus 9, that will get cancelled, divided by 0.141, 2 plus 4 plus 8. What is the answer? VO is equal to 893.6. volt. We got this one as 893.6 volt. Next, potential at D due to all the three charges is 1 by 4 pi epsilon naught A, that is 2 into 10 to the power minus 9 divided by AD, plus 1 by 4 pi epsilon naught 4 into 10 to the power minus 9 divided by BD, plus 8 into 10 to the power minus 9 divided by CD. What is the answer? Can you calculate? Substitute before that. Minus 9 into 1 by AD 0.2 plus 4 divided by BD 0.283 plus 8 divided by 0.2. What is the answer you are getting here? Take a calculator and solve. 577.2 volt. We got it as 577.2 volt. What is the answer you got? Did you get the same? Use the calculator. Did you get the same? Next, what we have to do? We have to calculate the work done to move a charge 2 nanocoulomb from D to the center. So, to move from D to center. Correct? So, VO minus VD. Potential difference is equal to what is the potential difference? 893.6 minus 577.2. Subtract, you will get one answer. So many volts. Everything myself only solving will not help. The next step, work done is equal to potential difference into the charge, that is 2 nanocoulomb. So what is the answer? So V into 2 into 10 to the power minus 9. This V is this one. Substitute that V and calculate the work done. What is the work done you are getting here? The work done is, I'll write the final answer, that is 632.8. 632.8 into 10 to the power minus 9 joules of work has to be done to move a charge 2 nanocoulomb from D to the center of the square O. So, this is how you have to solve. Very easy and simple, right? Am I right? It's very easy and simple. Next, can you write one homework problem? Will you write one homework? Try to solve one homework. Same type of problem, okay? We'll change this charge. Same question, only we will change the charge. That is 6 nanocoulomb, 12 nanocoulomb and 24 nanocoulomb are placed at the corners ABC of a square ABCD of side 0.2 meter. Calculate the potential difference between D and center of the square. You have to calculate only the potential difference from between the D and center. No work done. You have to calculate the potential difference. Calculate the potential difference between D and center of the square. Same type of problem. Draw a square, rough diagram of the square, place the 3 charges and mark the diagonal. Then sides has 0.2 meter. Calculate just as you have calculated for this problem. In the same way, calculate the values of OA, OB, OC and OD. Then using the expression of the potential, substitute and calculate the VO and VD. Then you have to subtract which one, you have to see the difference between D and O, VO and VD and solve it. Okay? Try to solve this problem as a homework. I hope everyone is solving the homework problem, but I am not getting the answers. Please send me the answers, solved answers, which you are solving it in a homework. Okay? Thank you.